more effective and efficient manner. There's also an expectation that intelligent grid management will allow for self-healing or faster recovery from failures, including the concept of microgrids. And the microgrid is really, if you like, a throwback to how the power system operated in years gone by as a group of independent, separate grids, where each separate grid was responsible for its own generation and load management. Right now, all of those separate grids are integrated into a larger power network. So the concept of microgrids is that when necessary, the microgrids could separate themselves from the larger interconnected grid and operate independently, and by doing so potentially provide for a greater level of system reliability for the consumers in that microgrid. That selection to disconnect from the main supply grid could also be for economic reasons. So for example, a large industrial complex could be its own microgrid. It might have the ability to generate power locally, and one of the smart grid initiatives is to allow that microgrid to participate with the wider power network to decide when to schedule local generation, when it's more cost effective or more appropriate for the wider grid to take power from the grid. So thereby controlling the costs of operating that plant, minimizing those costs, and also ensuring operational continuity. And finally, it's intended to be interactive, and this I think is largely part of the North American concept of a free market economy in operation. The idea here is that there can be multiple suppliers of energy, and the consumer has more choice in how they use energy, when they use energy, and who they purchase that energy from. So by providing more information to both the suppliers and the consumers, it enables better control and better choice of how power is used. Let's move on, please, Georgia. Thank you. So in many ways, the components of the smart grid look a lot like the existing traditional power grid, in that we have a generation system, transmission, sub-transmission and distribution networks feeding off to the end consumer. And in a traditional power system, the power, if you like, flows downhill, or in this case uphill, from this diagram, from the generation source down to the end consumer. But there will be new equipment integrated into these various parts of the grid, and this new equipment is part of the intelligent backbone together with the communication system. So for example, right now we already have SCADA systems monitoring generation, transmission, and even down into distribution levels. There's currently a rollout of phasor measurement units at typically the transmission level. There is an expectation that there will be an increased rollout of flexible AC devices, smarter control for transmission systems, etc. There will be increased substation automation or increased automation within substations going down to a lower level into the distribution network. And we also expect that there will be intelligent microgrids appearing in the distribution and consumer networks. For the end consumer, a lot of what people are seeing is intelligent or advanced metering systems with some kind of demand response management, which I'll talk about shortly, and also the ability to integrate distributed resources. And this is, for example, a photovoltaic panel on a building, or a small windmill that could feed back into the power grid. So for many people, the smart meter is what they see as being the face of smart grid. And for some people, smart metering is all that smart grid is, but really it's only one small part of the entire system. And without the rest of that system, the smart meter does very little apart from permitting remote meter reading, which saves someone coming around and knocking on your door to read your meter. Let's move on, please. So this diagram was published in Nature in 2008, Professor Masood Amin is at the University of Minnesota, and he's been one of the people researching in this area for quite some time. And he has been engaged by the US government to run a think tank on smart grid. And he's a prolific publisher and has been out to Australia recently as an IEEE outstanding guest lecturer and was speaking on smart grid. And he gave me permission to use a few of his slides in these presentations. So this is a diagram of how he perceives the smart grid, or some of the components of the smart grid. As you can see, it's a collection of generation sources at the bottom of the page, the power network, plus new generation sources such as the wind farms shown on the bottom left-hand side, isolated microgrids shown on the right-hand side, which potentially can connect to the main grid or disconnect themselves from that main grid. There's a lot of sensors and processors spread around the various devices. In the end consumers, shown as the houses at the top, there can be intelligent consumption, so demand management, the ability to modify the power consumption at the end consumer, and smart appliances appear to be one of the ways of handling that. Also, we see distributed energy resources such as solar panels on buildings and offices and so on. So the smart grid is a collection of all of these things with further monitoring, control and communications across the entire power grid. And George, if you can just open up all the little arrows for us, please. There's a number of functions that these various technologies will permit. So first of all, we are seeing a wider spread or reach for the ability to do contingency analysis and system simulation in real time by having better information about what's happening out at the consumer end. There will be simpler methods for integrating distributed generation and also system power storage, which can be distributed out on the power network. And that could be things like battery systems. And one of the perceived possibilities here is for electric vehicles to be used not only as a way of using electrical energy for transportation, but also when they are plugged in, the ability to take power back out of the battery in the electric vehicle as a possible distributed energy resource. So that's one of the things that's being considered here. There's the possibility of the intelligent network being able to island into these microgrids and to rapidly heal itself in response to faults. With the expansion in system monitoring, there will be increases in the ability to do asset monitoring and online equipment monitoring, etc. And one of the primary drivers for the whole smart grid process is the idea of demand response. And this is primarily where the load at the end consumer can be controlled to match the available generation on the grid. And by doing that, we improve the power system availability and reduce the possibility of blackouts. There are many ways of handling this, and traditionally in Australia we have the ripple control systems that are used for hot water switching. So the consumers can sign up for a lower tariff for the switched power system for hot water systems, and that is basically turned on and turned off by the power company, the distribution system, in response to the availability of energy. So we have some of that done now on a fairly gross scale by the distribution systems. But the whole smart grid process is planning to move that further down to a smaller granularity at the individual consumer's premises, and to have the consumer encouraged, if you like, to use the power when the power company has most available. And the primary means that that's proposed to be done is by dynamic pricing. So the idea here is that we could publish the instantaneous price of energy down to the end consumer, and they can make a choice based on that price whether they want to use the power now or later. And of course that needs to really happen through an automated system. We don't expect the end consumer at home to be looking at the power price and deciding to switch their appliances on and off. So it really requires an intelligent consumer with intelligent systems in the premises, whether it's a home or a building or a factory. So that's the whole dynamic pricing and demand response idea. And there's it's almost a trademark dollars and watts concept in the US, where they're basically asking people to participate in the energy market with this dynamic pricing model and use the price to control the demand. Let's move on, please. So the way that this might look to the end consumer is something like this, and this comes from the Electric Power Research Institute in the US. The expectation is that the end user will have some kind of customer portal or control system in their home, which enables them to see, for example, what the instantaneous power price is, but it also acts as the control system for the intelligent household, where it uses the instantaneous price of power which comes from the utility to decide to operate the local appliances, to regulate the thermostat on the air conditioning or heating system, to possibly back-feed power from the photovoltaic cells back into the grid, and to decide when to charge or discharge an electric vehicle that's plugged in at the home. This system also has advanced metering, and it might be simply a meter for the entire load in the household, or it might include intelligent sub-metering of different devices within the home, and those different devices could be subject to different tariffs. There's also a communication system that goes back to the utility operations, where the utility can advise the household of the instantaneous price. It can read the meter and potentially provide other services. So this is how it's expected that the smart grid rollout will look to the end consumer. And for this to work properly, the control interface in the household has to be simple for the end user to use. And there's several ways that this might end up working. So move on to the next slide, please. These are a few examples of the home interfaces that are currently available in pilot programs in North America. As you can see, some of them simply plug into a normal domestic power point, and they can receive wireless information indicating something about the power price possibly, or the time until the next change in the power price. So this is the kind of interface that it's expected that some users will be given and allow the user to make some choices. So for example, one of the possibilities that's seen is that a consumer might sign up for a tariff from their distribution company where they promise to have a peak maximum demand of, say, 5 kilowatts. The home automation system will monitor their instantaneous demand. And so, for example, suppose they have the clothes dryer running and it's consuming 2.5 or 3 kilowatts. If the user then goes and plugs in the toaster and the kettle at the same time, their instantaneous demand potentially could exceed 5 kilowatts. But the intelligent home automation system would detect this and might send a signal to the clothes dryer to turn off the heating element until the toast is finished or the kettle is finished boiling, and then the heating element can be turned back on. So in this way, the home automation system monitors the usage in the household, and it controls that usage in order to meet the service commitment that that user has signed up for, and therefore allows them to get the pricing that they have signed up for. And there's communication running between the end user's home automation system and the utility that basically confirms that they are operating with the system, confirms that they have stayed within their maximum allowance of energy, and so forth. So let's move on. Georgia, please. There is a conceptual model behind all of this, and again, this comes from EPRI and the North American National Institute of Standards and Technology, who have put together a roadmap for smart grid. And they see these various domains as participating in the smart grid. The traditional power flow is shown here in the dashed electrical line running from generation through transmission and distribution onto the end consumer. But in addition to that, there are these blue lines which show various communication interfaces and information flows between the various participants in the whole program. In our traditional power system, obviously we have the generation, transmission, distribution and end users, and we have operational monitoring and maintenance for those various systems. In recent times with deregulation, we also have the market operator participating in this whole system, where the market operator manages the financial control of generation scheduling and load. And there'll be a new participant here, which is the service provider. The service provider is really enabled by the smart grid because they are providing information and services to the end users and to the operations network for distribution and transmission. Potentially the service provider could act as an aggregation point for load, so that these service providers effectively buy the power from the distribution network and that the end consumers pay the service provider for whatever service they've signed up for. That's one of the new potentials with this system. Let's move on, please. Also behind this there is a physical structure. So we have the traditional generation, transmission and consumer of the power system, plus we have the market operators and the regulatory aspects of it. So that's the traditional left-hand side of this diagram. But now we're adding a communications and networking overlay for the management of this. And so this involves wide area networks, enterprise networks, and so on down to the home or premises network. So there's another view of the smart grid, is to look at it as both a power system and a communication system, or a system of these systems. Next slide, please. There's also another body participating in this whole area, and that's the GridWires Architecture Council. And they are looking at the various information flows and the business objectives of the different participants, and also the meaning or the syntax and semantics of the information that's being transferred, and also issues to do with technical connectivity of information between systems. So they basically have a layered model looking at different aspects of information flows, why the information is being sent between various users, and the regulations that might need to be applied to that. Plus, there's a number of issues that cut across all those areas which are shown on the right-hand side of this diagram. So this comes from the GridWires Architecture Council, and you can download their documents and read the volumes of information about each of these different categories and areas and the issues with the cross-cutting issues. Next slide, please. So this is an example of the various data flows that take place between the various participants. So these are the same domains as we saw in the cloud model earlier, but here we are seeing these lines demonstrating the different kinds of information transfer between different particular applications. And as I think you can see from this, it's a complex model with many participants, many kinds of information flows, and each of those information flows has different effect or different mechanisms for being transferred. So it's not like the traditional SCADA grid, if you like, which is a wide area network with one kind of information basically flowing. It's a much more complex system. So if you take nothing else away from this talk, smart grid is not just one thing. It's a complex system of systems that all interact. And there's a lot of information flow associated with this. Some of this information flow is really enterprise to enterprise or business to business, and that operates probably over the wide area internet using cloud computing concepts. Some of the traditional SCADA transmission style information flows still operate pretty much as they do today, and that is part of smart grid. So what we already have does not go away. We're just adding more on top. New information flows, new participants, new technologies, and a lot of new standards. And it's been identified there are something in the order of 40 different standards involved in different areas of the smart grid. And one of the challenges is to coordinate information currently handled in one place and transfer it to others. So the coordination between standards is a whole new area that's been identified by NIST, and there are a number of things called priority action plans that are currently in place to develop new standards to address the gaps that have been identified in this communication system. So let's move on, please. So why are we doing this? Well, primarily it's because our power consumption is increasing and we cannot continue to go the way we are. This graph here shows new power plant commencements in gigawatt generation load for 2007, and basically the colour scheme is blue for gas turbines, red for steam plant, and cyan for hydro systems. The black bars are coal-fired boilers. If you notice here, the largest black bars towards the right-hand side are from companies that you may or may not have heard of: Dongfang, Shanghai Electric, and Hua Electric. And basically that's China ramping up their steam coal-fired generation. So first of all, you might say, well, this is strange. One of the reasons that this is happening is because China is looking to grow their electric generation capability to be about a third of the kind of per capita generation and electric load that we're used to seeing in Western countries. So it's not an outlandish thing that they're doing, it's just they're playing catch-up, and they have the plans to generate an enormous amount of power, and they need to use a lot of fuel. Now your first reaction here might say, well, that's ridiculous, why are they using coal? And the answer is probably because it's available, and it's one of the sources they're looking at. China also spent more on smart grid in technology and research last year than any other country in the world, including the US, who announced a huge program of government-funded support for research and development and integration of smart grid technologies. So China is looking at this as one of the ways that they can meet their future demand. But in the meantime, the takeaway lesson here is there's huge growth in generation. Next slide, please. So people say, well, okay, we need to do something better than we're doing. How about electric cars? And there's something that people often forget, and that is the electric energy for the car has to come from somewhere, and normally it comes out of the power grid. So looking at the comparative efficiency of energy sources, if we have a normal internal combustion engine running on petrol, it's maybe 15 to 20% efficient in terms of energy coming out of the back going to the transmission and the driveline. That whole chain gives us an efficiency something like 15% from the fuel going in to actual productive motive power coming out the back. Now with a battery and electric motor, the efficiency of energy storage and conversion is much higher. However, that energy comes from the power grid. So whilst the transmission system in the car might be something like 70% efficient from the energy going into the battery to what comes out propelling the vehicle, when you take the 30 or so % efficiency of the power grid, that drops down to being around maybe 20-25% efficiency from the raw energy source until it comes into driving the car. And if you look in terms of CO2 production from burning coal, which is what happens in Australia for the majority of our energy, the CO2 production for that is higher than it is for burning petrol. So it's very simplistic to just say electric cars are an answer. I'm not knocking them. It's a good thing to do. And if we can charge them from solar cells or wind turbines, that's great, because that really is free. Next slide, please. So there is a report from EPRI to NIST about smart grid, and this was mainly looking at the issues with the roadmap, where the gaps were with interoperability and with standards. And there's also a podcast that you can download about that, which you can listen to as you're driving to work or on the train. Next, please. Also, there is a large body of work going on within NIST regarding cyber security of all of those information flows that we looked at before. And it's using basically the grid roadmap and the North American FERC, the Federal Electric Reliability Council, I think that is, has labelled a number of different application areas. So, for example, wide area situational awareness is basically traditional SCADA, monitoring of the system, looking at how it's operating. They're looking at all of the all of the information flows between the various participants and systems, and analysing if those information flows require security. If so, what kind of security? What measures can be taken? Do they need to be encrypted? Do they just need to be authenticated? Or does it not matter? You know, they can be clear text. So there's a report on this available from EPRI. There's a draft report published in February, and nominally comments have closed, but the review is still under discussion, and I'm sure if you submitted more comments they would be considered. Next, please. And there's a lot of information available on the web, so you can follow these various links and look at that to your heart's content. The last one there from Germany is interesting, for me at least. The Europeans have a very different focus on the smart grid. They're looking at it really as a way to become greener and to reduce carbon emissions. And their focus is less commercial, if you like, and more on environmental aspects. The US focus is much more on a commercial basis. So part of the reason for all of this is that we have constraints on generation and transmission. We need to learn to improve how we use energy. We need to improve our efficiency. We need to allow for the management of the load on the grid so that we can cope with increasing variability of generation as we integrate more renewable resources such as wind turbines and photovoltaic cells. So this slide will be available to you after the presentation, so you can follow these links at any time you like. That was about all I wanted to say, but there's some time for questions, and I think I might hand it back to Ray to manage that.
Thank you very much, Andrew. That was excellent. It's hard to cover what's such a broad gamut of issues within a short period of time, and you certainly got us thinking. Now, could I perhaps ask the group that's listening or has listened to Andrew if they've got any questions themselves as a starting point? Georgia, is there an avenue where people could raise their hand and ask questions?
Yes, there is. Attendees can raise their hand, which should be on their control panel. Otherwise, you can just type in your question and send it through. Okay.
So, is there a question that the attendees have? Well, I've got one to start off with, Andrew. It's of recent that I guess that there's been a whole lot of discussion around smart grids. Why has it become such a topical issue of recent? What's driving this? Georgia, can Andrew be on the line?
Sorry.
Yeah, that's it. Georgia had turned me off, so I couldn't cough all over the microphone. Thank you. Yeah, it is an interesting question, and I think the primary drivers are that we've got this situation. We've gone from having a power grid where the simple operating model was to have excess generation online available in order to meet the fluctuation in demand, because the electricity is the ultimate consumable resource. You have to generate what you need as you're using it. You can't. It's very difficult to store, so though there are some storage technologies, obviously. So we've gone from that model of just build more power stations so that there's enough, and build more transmission lines so that they're capable of transmitting that energy from generation sources to wherever it's needed. We've gone from that through a bit of a NIMBY kind of attitude of not in my backyard to now to the point where we've pretty much adopted the banana stance. And banana is build absolutely nothing anywhere near anyone. So what that means is nobody wants new power stations, nobody wants new transmission lines, but we still want to have our lifestyle where we're consuming increasing amounts of energy. So one thing we could do is change the way we use energy so that we can live within what we currently generate and can currently transmit. And so the way of handling that is really to manage the fluctuation in demand. Or one of the ways is to improve our efficiency and manage the fluctuation in demand so that we reduce the size of the peaks. That will buy us some space, but we also need to have probably distributed energy resources such as wind farms, photovoltaic cells, etc., distributed around the network so that we're not relying on bulk generation and large transmission systems, though we also do need to reinforce those in order to carry power from the sources that have, for example, large wind resources where we can place wind farms that typically are not going to be right next to the load centres. So I think it's mainly addressing the issue of increased demand, the reducing ability to simply meet that demand by traditional means, and now with environmental concerns, how to generate energy more efficiently and more cleanly as well, and the whole climate debate and CO2 production, etc. I think these factors have all come into it. Plus we now have emerging technologies where we do have communication systems that could permit us to do these things that probably traditionally would simply uneconomical.
Mm-hmm.
Okay, I've just had another question come through.
Yep.
It's from Andrew, and he says, where is Australia in terms of development?
For smart grid, that's an interesting question. The Victorian government, I think last year, maybe a little earlier, decided that they would engage in a smart meter rollout. My understanding is that someone said to them, smart meters will save CO2. And someone said, good, let's do it. I think the story that smart meters and the rest of the smart grid infrastructure together are required in order to manage CO2 reductions was probably lost. And in fact, if you simply put out smart grids and do demand response control, which basically reduces the peak load of the end user during the evening and morning peak, what it would do is allow us to burn more brown coal in Victoria. So it would probably increase the CO2 production in the short term until we have increased rollout of wind farms and similar technologies with renewable energy resources. So we've got part of the story. Now, it might sound like I'm being a bit cynical there, but we do need to take these steps, but they are only steps on the path to doing the whole thing. And the whole smart grid is much more than just smart metering. But that's pretty much the public face. Now, having said that, the people responsible for the power system in Victoria are well aware that they've got to roll out all of the smart grid technologies in order to have proper demand response management, real-time pricing, and the network responsivity that they can then integrate more renewables. So they're not blind to the facts, it's just the public is probably not made aware of them.
Okay, I also have another question. This one's from Ali. He says, has smart grid technology ever been used in Australia, and are there any specific projects?
Good question. I'm not aware of any wide-scale projects. I believe there are some small proof-of-concept programs running. I think there's a couple of microgrid style programs being undertaken mainly by large industrial plants who operate their own can operate their own microgrid, and do have on-site generation ability, but I'm not aware of any large-scale plans. I am aware that many of the power utilities are looking at these things and doing research, but I'm not sure of how much that's rolled out.
Georgia, could I perhaps just ask you, I understand you've done some internal research and you found that there was a pilot project in New South Wales at Newcastle for $100 million for a smart grid project. Perhaps that's information we could be able to pass on to Ali or whoever else is interested. But I understand that there is a smart grid, smart city project rolled out across 50,000 homes in 5 sites across New South Wales. And it's within the suburbs of Sydney CBD, Newcastle, Ku-ring-gai, and apparently they're rolling out 12,000 monitoring devices to service the homes in these different suburbs. So perhaps if we have that information, we could at least pass that on. Georgia? Hello?
Yes, that's fine. Sorry, I just muted myself.
No, no problem.
I've got another question come through. When we're talking about smart grids, is it going to be on a national level or on a state level, at least in Australia, with a standard body?
Well, that's a good question. That's getting into the political realm. Right now, we have the Australian Energy Market Operator who manages the interconnected grid on the east coast that runs from the north of Queensland right through to South Australia and a little way towards Western Australia, but not much past Adelaide. That body will continue to be the grid operator. The smart grid technologies will provide them more information than they currently get, or the ability to have information at a finer level of granularity. So I don't think that will change, but the operation of grids and the management of the market is largely a political rather than technical issue, and that's a bit beyond my area, so I really shouldn't speculate much more.
Okay. We also have someone who would like to ask you a question, so I'll just unmute them. Babek? Hello?
Hello, yes, I'm just going to send you my question. My question is about the communication within the smart grid. As Andrew already mentioned, is there any standardization in smart grid has been done or in the progress, like the integrated system for the communication, like for substation we have IEC 61850, as you know. Yep, thanks.
Yes, this is the area that that NIST is looking at and EPRI are looking at, and I'd recommend to you to go and download the EPRI report to NIST and read through that. That discusses that very question, and they identified something in the order of 40 plus standards involved with communication systems and data modeling systems that apply in different areas. And so it spans the range of things like TCP/IP, WiMAX, ZigBee, etc. for just the backbone. And it looks at things like 61850 in substations, DNP3 for SCADA, other communication systems. There's a thing that the Americans are using in the distribution arena called Multispeak, and I don't know much about that, but it's widely used in that area. So there's a lot of different standards, and one of the issues that is seen is that there is information about the power system available in contained pockets within the existing grid, and its smart grid integration will be partly about transferring that information between the different areas that currently have it, including the semantic description of that data. So it's not just here are the values, but what does the value mean, and what's the meaning of the data. So there's a lot of work going on to create new standards for interoperability between existing standards, and that is part of the smart grid adoption work that is being run in North America at least. In Europe it's being handled a bit differently. The IEC do have a working group looking at smart grid technologies and integration, and they are also looking at how to improve or integrate the data sharing between the different participants.
Okay, I've also got another question. It's from Farzad, and he says, do you think the smart grid will be applicable in Australia, as it is a very wide country and may need more infrastructure for the network?
The answer is yes, I do believe it's applicable, and part of the main reason I believe it's applicable is we cannot afford not to do it. And that's basically because adopting smart grid will lead to increased energy costs. Sorry, that's my view. I don't know that's going to be a fact, but that's how it looks to me. But if we don't adopt smart grid and we attempt to continue operating the power system as we have using traditional methods, the cost increases will be significantly higher, the environmental impacts will be significantly higher. I think the only option we have is to adopt smart grid technologies as an enabling tool to allow for the wider integration of renewable resources and the improved control and efficiency of the grid so that we manage and contain our energy consumption. It would also be good to encourage the widespread use of more efficient appliances and the like, and a lot of public education will be required, plus a lot of work from manufacturers to build new kinds of appliances that really do work better. Because up till now we've been driven by an economy where energy is very, very cheap and we just use it as we wish. And the days of that are coming to an end.
Andrew, Georgia, could I just perhaps make a comment on that?
Sure.
Andrew, you said an interesting thing. You said that we can't afford not to go ahead with this because there will be a price increase if we go ahead with smart grids, but there will be an even higher increase if we don't. Is that correct? Did I hear that correct?
You have paraphrased it very well.
Okay. The question that I have then is that the biggest issue then is consumer take-up, because no one likes a price increase. So the fact that it's a small price increase as against the higher price increase that could come about because of the fact that there's climate change issues, it would seem to me that educating the general population is probably the biggest facilitator for, doesn't matter whether it's smart grids, whether it's renewables, whether it's climate change, whether it's carbon trading. Why doesn't the government, I guess, put aside a policy of putting that through schools at, say, the year 10, year 11, year 12? Because this isn't something that's going to happen in the next 1 or 2 years. So at least as children are coming out of schools and at the year 10, 11, 12, in the next 5 years they will be, I guess, voting and I guess voting with their votes to I guess take this forward, because they would understand the issues much better.
It's a good suggestion, and I like it. Yes, the public does need. It would be useful for the public to understand better what this is all about. There was a survey done in the US in February this year, I think, that found that 68% of respondents had never heard of smart grid and had no idea what it was, consequently. There was also a lot of concern amongst Americans about the idea of having an intelligent meter in their household that could detect their instantaneous power consumption. And the Americans have this thing about privacy where they don't want you to be able to know how much power I'm using, because you might work out that I'm doing something that uses power. It's a very curious view, but anyway. But the main outcome from that survey was that there was a large public ignorance. People who did know about smart grid, the majority of them did expect there to be a small increase in cost when they have a smart meter in their house, for example. But there was generally not an appreciation that if they didn't have this, there would be much larger cost increases. So yes, I agree, cost increases are unpalatable, and they are probably most keenly felt by that part of the population that least can afford. So I think there are things people can do today. For example, you could manage your own load and reduce your load intelligently by doing certain things. And I know of an example of a householder who has water supplied from a well with a pump. By reducing the static pressure on their pump, it did not run as frequently to create as high a pressure, and therefore they saved energy. It was a very simple measure. No one in the household noticed that there was less pressure of the water supply, or no one commented on it at least. So there's things that we can do if we are proactive about it, but that's the individual, and I don't think most individuals have that level of understanding or interest in doing so. So consequently, we really need to have this put upon us from above, if you like. And the whole smart grid thing is a huge system of systems, and it's not up to the individual to choose to be in it or not. It's very much the kind of thing that the utilities and the supply side really need to roll out to the consumers.
That's great, Andrew. I think we might need to probably wrap up the discussion, not because of the fact that there is any shortage of questions. I'm sure that this has raised more questions. And what I might suggest is if people have, that the attendees have found this useful, maybe there can be a follow-up and we can have perhaps a different slant to this discussion. But at least the promise was that we would have this for the hour, between 12 to 1, and it's close to 1. So could I, on behalf of Fandor Electrical Jobs, congratulate Andrew on a wonderful presentation, and thank you very much for devoting your time and I guess getting us up to speed with this topic.
Well, thank you very much for the opportunity, and I really just scratched the surface. And I should point out that a lot of what you've heard is my interpretation of what I'm seeing, and if you listen to other people, they will give you perhaps a different spin on some of these things. But hopefully, you know, the underlying facts and the documents available on the web will give you a lot more information and detail about the technologies and the plans. So thank you all for listening, and thank you, Ray, for inviting me.
Pleasure. Bye-bye.
Good. Thank you.
Thank you, Georgia. Goodbye.
If the attendees are still there, I'd also like to thank Georgia. That's actually certainly been instrumental in putting this together. Thank you very much, Georgia.
Thank you.
Bye-bye.
Just for any attendees that are still online, we have recorded today's presentation, so once it's been edited, we'll have it on our website within about 2 weeks. And if anyone would like the slides, please email me at Georgia, spelt Georgia, at Sustainergy, SUSTAINERGY.com.au. Thank you.